All right, let's look at the homework 2.1, problem number 10. All right, so we have this cubic function, f of x is equal to x cubed minus 6x squared. We want to find the derivative using the definition. All right, so let's do that. All right, so remember the definition of the derivative is the limit of the difference quotient. So we're going to get something like that. So that's the definition, right? Right, so what we need to do is we need to start rewriting, right? So let's work on f of x plus h, right? So to get that, all you have to do is every time you see x, we're going to put x plus h in there, right? So let's start doing that. So I'm going to actually go ahead and replace this. So you're going to have, right, I see x here, so we're going to put x plus h instead. And then you have to cube that. So it's going to look something like this, right? Then you have a minus 6. So I'm going to go ahead and put that in. So minus 6 in there. And then you have to multiply by x, which is replaced by x plus h, right? So we have that, right? So this is f of x plus h, right? Then we still have to subtract the f of x. F of x is exactly that, so I'm going to copy the formula. So f of x is x cubed minus 6x squared. So we get that, right? Then we just need to multiply it out. So I'm gonna do that. So to multiply out this cubic part, right? And I'm gonna use this formula here. A plus b quantity cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed, right? So x is my a here and h is my b there, right? So let's go ahead and multiply out. So we're going to have x cubed, right? Put that in there, right? Then you're going to have plus 3x squared, so please 3x squared h, right? Put that in there. And then plus 3xh squared. Then we're going to have plus h cubed, right? So plus h cubed, right? Got that. So if you multiply this out, you end up getting those four terms, right? Then you have negative 6, so minus 6 there. All right, then we have to multiply by, I forgot something. There should have been a square there, right? Sorry about that. So there should have been a square, right? So we have to multiply it out. So let's go ahead and multiply out. So we know that a plus b squared is a squared plus 2ab plus b squared. So I'm just going to apply that to find, right? So we're going to have x squared, right? Then you're going to have plus 2xh, and then we're going to have plus h squared, right? So plus h squared, right? So we got that. So if you multiply out, you're going to get those three terms. All right, last two terms, I'm going to simply distribute the negative to x cubed. So you're going to have minus x cubed, all right? Then it's going to be distribute the negative sign, so it's going to be a plus 6x squared. So we're going to have, let's say, plus 6x squared, right? So we get that. All right, then we can cancel things out, right? So you can see that you have x cubed here and minus x cubed. So I'm going to go ahead and cancel that. So cancel x cubed with the x cubed over there. So cancel. Let's see those two. Let's see, right? So we cancel x cubed, right? What else can we cancel? Let's see. Here there's a negative 6x squared. There's a positive 6x squared. So we can cancel 6x squared. So I'm gonna cancel those guys, and let's see, I'm going to cancel those two, see what it looks like. All right, so I cancel those. All right, then as you clean up, let's see, if you clean up, you're going to end up something like this, right? So I just collect all the leftover terms like that. And here I actually distributed -6 to 2xh. So you're going to get -12xh. Then -6 to x squared. So you have -6x squared, right? And if you look at the numerator, you can see that every single one of them has at least the h in it. So I'm going to pull out the h from the numerator. Right, so go ahead and do that. All right, so you see that if you pull out h here, you have 3x squared left. Right, pull out the one of the h here, so you're going to get 3xh left. And pull out the one of the h, you're going to get h squared. And pull out the h here, you have 12x. Pull out one of the h here, you get -6h. Right? Then we have a factor h on top and the bottom. So we can cancel those out. So we're going to cancel h on top and also cancel h on the bottom. Right? So you get this. Right? So clean it up. You're going to end up getting just the expression inside the parentheses. All right, then we know that here, as h approaches 0, 3x squared has nothing to do with h, so it's going to stay exactly the same. Right here, second term, h goes to 0. 0 times anything is 0, so this is going to be 0. And h squared, 0 squared is 0. -12x stays the same because it has nothing to do with h. Right, -6h goes to 0, so what's left would be 3x squared minus 12x. So that's exactly what we found as the derivative. Right, so 3x squared minus 12x. Right, let's type it in. Right, so we found the answer to be 3x squared minus 12x. Right, let's go ahead and check the answer. All right, I came back and looks like we got this one correctly. All right, so let's do the second part. Use a graphing utility to graph f and its derivative. All right, so I'm going to pull out the GeoGebra here. All right, so original function was f of x, right, is equal to x cubed minus 6x squared. Right, so hit enter. Right, so maybe we should rescale a little bit so we can see a picture. So go back and maybe rescale a little bit here so that we can see better. And here. Right, so this is the graph of the original function f. All right, and we want to graph its derivative. And the GeoGebra actually knows how to take the derivative. I'm going to take advantage of that. So f prime of x and hit enter. So you see that we have the correct answer here. So you're going to have a parabola. So this is the f prime. So red is f prime. The green is the original function f. All right. So let's look for the correct picture here. All right. All right. So first one doesn't look like it. All right. Second one doesn't look like it either. All right. And the third picture. All right. This looks, this is the one. It looks like you have a parabola, and this is original function. Parabola is upside down there. So correct answer is this one. Right? I'm going to go ahead and answer the third part. What do the x-intercepts of the derivative indicate about the graph of x? All right, so let's look at the picture. All right? So x-intercept of the derivative would be at the 0 and 4. As you can see at 0 and 4, you can see that here, original function f has a horizontal tangent line here. And here, another horizontal tangent line. So the x-intercept, because since the derivative is 0, which means that the slope of the tangent line is 0. So you're going to have a horizontal tangent line. So the answer for this is going to be, let's see, oh, actually we cannot see this. Right, so answer would be horizontal tangency. Right, so let's go ahead and check the answer. All right, we came back and looks like we got the correct picture. So that was the correct one. And we have horizontal tangency. That is also correct. All right, that's it. I hope that this was clear.